Hey, you! Ever wonder about everything? Have you ever watched a fizzy drink bubble and pop? Or seen bread dough rise up like magic in a warm oven? Maybe you've wondered why fireworks explode into so many brilliant colors, lighting up the night sky. Well, guess what? That's all chemistry in action. It's not some dusty old subject found only in textbooks. It's happening all around you all the time. From the tips of your toes to the distant stars, chemistry is the science that explains the what and how of the stuff that makes up our universe. It's pretty amazing when you think about it, isn't it? This isn't just for brainiacs in lab coats, it's for everyone. Now hold on to your hats, because we're about to embark on a fantastic journey into the world of chemistry. Don't worry, we're not going to start with super complicated formulas or terrifying equations that make your brain feel like scrambled eggs. Nope. We're going to explore the basics, the really cool fundamentals, in a way that's fun and easy to understand. Think of this as your friendly guide to the secret lives of tiny particles and the incredible things they do. We'll uncover the mysteries of matter, see how different substances get together and party, and discover how chemistry shapes our world in countless ways. It's going to be an adventure. Why should you care about chemistry? Well, because chemistry is like having the instruction manual for the entire universe. Understanding even a little bit about it helps you understand yourself, your world, and why things work the way they do. It's like knowing the secret recipe for, well, everything. Chemistry helps us solve problems, invent new things, and make our lives better, safer, and healthier. It's the ultimate Lego set, where the pieces are atoms and molecules, and the possibilities for building cool stuff are absolutely endless. It's the science of change, the science of creation. So get ready for an awesome exploration. We're going to peek into the incredibly small world of atoms, those fundamental building blocks of all matter. We'll see how these atoms don't like to be alone and how they team up to form all sorts of interesting combinations called compounds. Then we'll dive into the exciting world of chemical reactions, where substances transform and create new things right before our eyes. It's a universe of wonder waiting to be discovered. And you've got a front row seat. So buckle up your seatbelts, because science is about to get seriously cool. All right, let's get down to brass tacks. What exactly is chemistry? Simply put, chemistry is the science of stuff. And by stuff, scientists mean matter. Matter is anything that has mass and takes up space. So, that includes you, me, the chair you're sitting on, the air you're breathing, and even that ham sandwich you might be thinking about for lunch. Chemistry studies what matter is made of, what its properties are, like its color, or if it's a solid, liquid, or gas, and how matter changes. It's the ultimate investigation into the nitty-gritty details of everything. Think about it. Matter is absolutely everywhere. From the gigantic stars burning billions of miles away to the tiniest microbe wiggling in a drop of water, it's all matter. Chemistry is the science that dares to ask the big questions about this matter. Why is water wet? Why is glass transparent? Why does iron rust? Why does ice cream melt? Chemistry provides the answers by looking at the fundamental particles that make up everything and how these particles interact with each other. It's like being a detective. But instead of solving crimes, you're solving the mysteries of the material world. How cool is that? Now, why does all this matter? Well, it matters a whole lot. Understanding chemistry is crucial for so many things in our modern world. It helps us develop life-saving medicines to fight diseases. It helps us create new materials that are stronger, lighter, or more sustainable. Think about the clothes you wear, the phone in your pocket, the food you eat. Chemistry played a role in making all of them. It helps us understand our environment, tackle pollution, and find new ways to generate clean energy. Without chemistry, our lives would be vastly different and probably a lot less comfortable. And here's a really neat part. Chemistry isn't an isolated island of science. It's often called the central science because it connects to so many other scientific fields. If you're interested in biology, you'll find that living things are basically incredibly complex chemical factories. Your body is performing millions of chemical reactions every second. Physics and chemistry overlap when we study energy and the behavior of matter. Geology uses chemistry to understand rocks, minerals, and the processes that shape our planet. Even cooking is a delicious form of chemistry. It's the thread that ties so much of our scientific knowledge together. Let's zoom in, way in. I mean, smaller than a grain of sand, smaller than a speck of dust, smaller than anything you can see with your naked eye. We're talking about atoms. Atoms are the fundamental building blocks of matter. They are the smallest unit of an element that still has all the chemical properties of that element. Imagine you have a bar of pure gold. If you could keep cutting it into smaller and smaller pieces, eventually you'd reach a single gold atom. Go any smaller than that and it's not really gold anymore. These atoms are the Lego bricks of the universe. So what are these tiny superstars made of? Well, atoms themselves have even smaller parts inside them. In the center of every atom is a dense core called the nucleus. The nucleus contains positively charged particles called protons and particles with no charge called neutrons. Think of the nucleus as the super important tiny command center. Whizzing around this nucleus, in specific regions or energy levels, are even tinier, negatively charged particles called electrons. It's like a miniature solar system, but the electrons don't orbit in neat paths like planets. They exist in fuzzy clouds of probability. It's a busy, dynamic little world down there. Now let's talk about elements. An element is a pure substance that is made up of only one kind of atom. All the atoms in a sample of the element oxygen are oxygen atoms. All the atoms in a chunk of carbon are carbon atoms. Scientists have discovered and organized all the known elements into an amazing chart called the periodic table of elements. It's like a giant family portrait for all the different types of atoms in the universe. Each element has its own unique symbol, like O for oxygen, H for hydrogen, and Au for gold, from its Latin name aurum. What makes one element different from another? It's all about the number of protons in the nucleus. This number is called the element's atomic number, and it's like the element's unique identification code. For example, every hydrogen atom has exactly one proton. Every helium atom has exactly 2 protons. Every carbon atom has 6 protons. This simple difference in the number of protons changes everything, giving each element its distinct properties. Isn't that incredible? Just changing the number of protons creates a completely different substance with completely different behaviors. Science is amazing. Atoms, those tiny building blocks we just talked about, are often quite social creatures. They don't always like to hang out by themselves. Instead, they love to team up with other atoms, especially atoms of different elements. When atoms of 2 or more different elements chemically bond together, they form something new and exciting called a compound. Think of it like ingredients in a recipe. Flour is one thing, sugar is another, and eggs are something else. But when you mix them together and bake them, you get a cake, a compound with totally new properties. How do these atoms team up or bond? It mostly has to do with their electrons, those negatively charged particles whizzing around the nucleus. Atoms want to achieve a stable arrangement of electrons, kind of like how people want to feel comfortable and balanced. To do this, they can either share electrons with other atoms, forming covalent bonds like a friendly handshake, or they can transfer electrons from one atom to another, forming ionic bonds where one atom gives an electron and another takes it, creating charged particles that attract each other. These chemical bonds are the glue holding compounds together, and they're incredibly strong. Here's the really mind-blowing part. When elements combine to form a compound, the compound has properties that are completely different from the original elements. Take water, for example. Its chemical formula is H2O. That means it's made of 2 hydrogen atoms and 1 oxygen atom. Hydrogen is an explosive gas. Oxygen is a gas that fire needs to burn, but when they combine, they form water, a liquid that we drink and use to put out fires. Or consider table salt, sodium chloride, NaCl. Sodium is a soft silvery metal that reacts violently with water, and chlorine is a poisonous greenish-yellow gas. But together, they make the tasty stuff you sprinkle on your fries. Chemistry is full of these amazing transformations. Compounds are absolutely essential to, well, everything. Most of the substances we encounter in our daily lives are compounds, not pure elements. The sugar you put in your tea, sucrose, the plastic in your water bottle, polyethylene, the carbon dioxide you exhale, even the complex molecules that make up your DNA. These are all compounds. They are the workhorses of the chemical world, forming the basis for rocks, plants, animals, and all the materials we use to build our world. Without compounds, life as we know it simply wouldn't exist. Pretty important stuff, these compounds. Section 5, Chemical Reactions. Let's get this party started. So, we know about atoms and how they can team up to form compounds. But how do these changes actually happen? The answer is through chemical reactions. A chemical reaction is a process where one or more substances, called reactants, are transformed into one or more different substances, called products. It's like a cosmic dance party where atoms rearrange their partners. The atoms themselves don't change their identity. A carbon atom stays a carbon atom, but they break their old bonds and form new ones, leading to completely new molecules with new properties. It's like taking Lego bricks from a model car and rebuilding them into an airplane. Same bricks, different structure. How can you tell if a chemical reaction is happening? Sometimes it's obvious. You might see a color change, like when a green tomato ripens to red. You might see bubbles of gas forming, like when you drop an antacid tablet into water. A reaction might produce light or heat, like a crackling campfire or an exploding firework. Sometimes a solid substance called a precipitate might form when you mix two liquids together. Your senses are often your first clue that atoms are doing their rearranging dance. Even the browning of toast in your toaster is a series of complex chemical reactions. There are many different types of chemical reactions, but let's not get bogged down in too many fancy names right now. Some basic types include synthesis reactions, where two or more simple substances combine to form a more complex one, like A plus B gives you AB. Think of making a sandwich from bread and cheese. Then there are decomposition reactions, which are the opposite. A complex substance breaks down into simpler ones. AB gives you A and B, like water splitting into hydrogen and oxygen. Combustion reactions are another common type. That's just a fancy word for burning, which usually involves a substance reacting rapidly with oxygen to produce heat and light. One super important thing about chemical reactions is energy. Almost all chemical reactions involve a change in energy. Some reactions release energy into their surroundings, usually as heat or light. These are called exothermic reactions. A burning log is a great example of an exothermic reaction. It feels warm. Other reactions need to absorb energy from their surroundings to happen. These are called endothermic reactions. An instant cold pack that you use for injuries is a good example. It gets cold because it's absorbing heat from your skin. This flow of energy is what powers everything, from our bodies to our cars to the stars themselves. Section 6. Chemistry's Hall of Fame. Pioneers and Breakthroughs. Chemistry isn't just a bunch of facts in a book. It's a story of discovery, built by curious people over thousands of years. Even ancient humans were practicing chemists without knowing it. Think about it. The first person to control fire. That was a major chemical discovery. Learning how to cook food, ferment grapes into wine, or extract metals like copper and bronze from ores. These were all early experiments in changing matter. They didn't have fancy labs or beakers, but they were observing, experimenting, and learning about the properties of substances. That's the spirit of chemistry. Fast forward a bit and we meet some incredible minds who really shaped modern chemistry. One giant is Antoine Lavoisier, a French nobleman often called the father of modern chemistry in the late 1700s. He was meticulous. Lavoisier named oxygen and hydrogen, figured out the composition of water, and established the law of conservation of mass, which states that matter isn't created or destroyed in a chemical reaction, it just changes form. He helped make chemistry a quantitative science based on careful measurement. Sadly, his brilliance couldn't save him from the guillotine during the French Revolution. Science, sometimes it's dangerous. Then there's Dmitri Mendeleev, a Russian chemist who in 1869 gave us one of science's most iconic tools, the periodic table of elements. Mendeleev arranged the known elements by increasing atomic weight and noticed that elements with similar properties appeared at regular intervals or periods. What was truly genius was that he wasn't afraid to leave gaps in his table for elements that hadn't been discovered yet. He even predicted the properties of these missing elements, and when they were later found, his predictions were astonishingly accurate. Talk about foresight. The periodic table is the roadmap for all chemists, and we absolutely must talk about the incredible Marie Curie. A Polish and naturalized French physicist and chemist, she conducted pioneering research on radioactivity. She was the first woman to win a Nobel Prize, the only person to win Nobel Prizes in two different scientific fields, physics and chemistry, and the first female professor at the Sorbonne in Paris. Her work with radioactive elements like polonium and radium, which she discovered, fundamentally changed our understanding of the atom and led to new medical treatments like X-rays and radiation therapy. She was a true trailblazer, overcoming huge obstacles in a male-dominated field. What an inspiration. Section 7. Chemistry in your cereal bowl and beyond. You might think chemistry only happens in high-tech laboratories with scientists in white coats, but guess what? Chemistry is happening all around you, all day, every day, even in your cereal bowl. When you wake up in the morning, the neurochemicals in your brain are firing, helping you become alert. The toothpaste you use to brush your teeth, full of chemical compounds designed to clean and protect. The milk you pour on your cereal is a complex mixture of proteins, fats, and sugars. The cereal itself has been processed and preserved using chemistry to keep it fresh and crunchy. Chemistry is inescapable even before your first cup of coffee. Think about your kitchen. It's practically a chemistry lab. Every time you cook, you're performing chemical reactions. When you bake a cake, the baking soda or baking powder reacts to produce carbon dioxide gas, which makes the cake rise and become fluffy. When you fry an egg, the heat causes the proteins in the egg white and yolk to denature and change texture. The browning of meat or toast, that's a complex series of chemical changes called the Maillard reaction, which creates all those delicious flavors and aromas. So next time you're whipping up a meal, remember you're a chemist in action. Chemistry doesn't just stay in the kitchen, it's a superstar team player with other sciences too. We already mentioned how biology is deeply rooted in chemistry. Life itself is a symphony of chemical reactions, from how plants use sunlight for photosynthesis to how your body digests food and builds new cells. Geology relies on chemistry to understand the composition of rocks, minerals, and the Earth's core. Environmental science uses chemistry to monitor pollution, develop ways to clean up contaminated sites, and find sustainable solutions for our planet. It's like the helpful friend that every other science needs. And it's not just the hard sciences. Chemistry even plays a huge role in the arts. The vibrant pigments used by painters throughout history are all chemical compounds, each with its own unique properties that determine its color and permanence. The process of developing photographs, whether old-school film or modern digital prints, involves intricate chemical reactions. The beautiful glazes that give pottery its shine and color are the result of high-temperature chemistry. So, from life-saving drugs to breathtaking masterpieces, chemistry is there, making it all possible. It's truly the science of everything tangible. Section 8. The future is chemical innovations and possibilities. Chemistry isn't just about understanding the world as it is, it's about shaping the future. Chemists are constantly working on designing and creating new materials with amazing properties. Imagine super strong yet incredibly lightweight plastics that could make cars and airplanes more fuel efficient, reducing our impact on the environment. Or think about flexible electronic screens that you could roll up like a newspaper, or even smart fabrics that can monitor your health. These aren't science fiction dreams. They are possibilities being explored right now, all thanks to clever chemistry. The materials of tomorrow are being born in labs today. Beyond cool new gadgets, chemistry is absolutely vital for tackling some of the biggest challenges facing our planet and our species. Chemists are at the forefront of developing new medicines to combat diseases like cancer, Alzheimer's, and emerging viruses. They are working tirelessly to create more efficient and affordable renewable energy sources, such as better solar panels that can capture more sunlight, or new types of batteries that can store more energy for longer. And of course, chemistry is essential for finding innovative ways to clean up pollution, purify water, and manage waste sustainably. Chemistry offers solutions. One of the most exciting frontiers in chemistry is nanotechnology. This involves working with materials at an incredibly small scale, the scale of atoms and molecules. At this tiny level, materials can exhibit completely new and unexpected properties. Imagine microscopic robots or nanobots that could travel through your bloodstream to deliver medicine directly to diseased cells, or smart materials that can repair themselves when damaged, just like living tissue. This is the realm where chemistry, physics, and engineering merge, opening up a universe of possibilities for medicine, electronics, and materials science. It's mind-bogglingly cool. And as we innovate, there's a growing movement called green chemistry, which is all about making chemistry more environmentally friendly. The principles of green chemistry guide scientists to design chemical products and processes that reduce or eliminate the use and generation of hazardous substances. This means finding safer alternatives to harmful chemicals, designing reactions that are more energy efficient, using renewable resources, and minimizing waste. The goal is to ensure that the chemical solutions we develop for today's problems don't create new problems for tomorrow. Chemistry can be and must be a force for a healthier planet. Section 9. So, what's the big idea? Chemistry rules. Wow. We've been on quite the adventure through the amazing world of chemistry, haven't we? We've zoomed in on teeny tiny atoms, seen how they get together to form everything around us, and watched them dance and rearrange in chemical reactions. We've learned that chemistry isn't just some abstract subject you study in school. It's the fundamental science that explains how the universe works, from the smallest particle to the largest galaxy. It's the story of matter, the story of change, and ultimately, the story of us. It underpins everything. Understanding the basics of chemistry gives you a kind of superpower. It's the power to look at the world around you and not just see things, but understand they are the way they are and they work. Why do leaves change color in the fall? How does soap clean your hands? How do batteries power your favorite gadgets? Why does popcorn pop? The answers to all these questions and so many more lie in the principles of chemistry. It's like having X-ray vision for the molecular world. Every day becomes a little more wondrous. The most important thing you can take away from all this is to keep asking questions. Stay curious. The world of chemistry is incredibly vast and wonderfully complex, and there's always something new and exciting to learn. Every discovery opens up new questions and new avenues for exploration. Maybe you'll be inspired to conduct your own simple experiments, safely of course. Perhaps you'll even become the next great chemist, pioneering discoveries that change the world. The universe is full of mysteries, and chemistry is one of the keys to unlocking them. So the next time you see a cake rise, a firefly glow, or even just water boiling in a pot, take a moment. Give a little nod to the incredible invisible world of atoms and molecules doing their thing. Because chemistry isn't just important, it's not just fascinating, it's everything. It's the basis of our existence and the engine of the cosmos. And understanding it, even just a little bit, makes life a whole lot more interesting. So go out there, observe, question, and remember, science rules.